Hello, good evening, and all. Welcome back for the session on haloalkanes. देखो, what we told you about haloalkanes. How do we prepare haloalkanes? So then we have told you the most important reactions of haloalkanes. What was the most important reaction of haloalkanes, students? That was nucleophilic
Hmm.
substitution.
Yes, sir.
The most important reaction is nucleophilic substitution reaction. Now the question, and in that we have told you such a large number of compounds we could prepare. We have given you complete table where you can prepare alcohol, ethers, amines. Then you could prepare nitriles, isonitriles, nitrite, nitro. And we also discussed ambident nucleophile. I said that's the most important part. That there can be nucleophiles. There can be species which have more than one nucleophilic center.
Hmm.
There are groups which has more than one nucleophilic carbon like nitrile and NO2. So the products which we obtained were different.
Hmm.
And we explained the reason for that. Now the
Yes, sir.
important question which will be coming in the exam is on mechanism of the nucleophilic substitution reactions. And the nucleophilic substitution reaction can proceed by two
Hmm.
different mechanisms. How many? Two. I'm saying they can proceed through SN2 second SN1. So what is the difference between these two and which alkyl halides will undergo SN2, which will undergo SN1? What will be the order of reactivity? That is what we have to see with the mechanism. See the first I'm trying to discuss with you here. First, I am discussing with you students here SN2 mechanism. What is the meaning of SN2? It is clear from here. Substitution, nucleophilic 2 means bimolecular. This is substitution, nucleophilic bimolecular. That means the rate of the reaction is going to depend on two. One is the nucleophile and second is the substrate. Second is the substrate. Now here we have shown you an example of that. Here I am showing you the example of that. For example, you can see here is an alkyl halide.
Hmm.
Can you see this alkyl halide?
Yes, sir.
Okay. You can see what I'm saying that what I have, you have a carbon, you have Cl supposing, or you can have Br, no problem. This is a leaving group. And I'm writing hydrogen. Here I'm showing a dark wedge. Here I'm showing the dashed H. I think you are familiar with these
Yes,
already.
sir. Yes, sir.
That is coming, pointing towards me. The carbon is tetrahedral in nature's sp3 hybridized. Here you can see hydrogen atoms are very small. Hydrogen atoms are
Very small.
very small in size. Very, very small in size. They are, I'm saying hydrogen atoms are very small in size. Okay?
Hmm.
Now the nucleophile, this has to leave. This has to leave. This is called the leaving group. What we call this? Leaving group. The leaving group will leave and the nucleophile will come. Since
Ah.
this is on this side, this is a plane of the paper, what we have shown. The nucleophile will come from the back side. This is my nucleophile. OH minus is a good nucleophile, you know.
Hmm.
These are the negative charge. These are oxygen having 6 electrons. So what is going to happen? This will come and attack the carbon. Why? Because
Yes,
carbon
sir.
is positive,
Hmm.
Cl is negative.
Negative. Yes, sir.
So the nucleophile is coming from the back.
Hmm.
It will attack this carbon. And
Yes,
since
sir.
hydrogen atoms are very small in size, there is no steric hindrance.
Yes, sir.
Steric hindrance or crowding. No crowding. It is not a crowded place. It is easy.
Hmm.
As atoms are very small, so it can come and attack this carbon, and this can leave. And what will be the result of this? This is a leaving group. This is the attacking reagent, nucleophile. So in between, we have shown a transition state. You can see that an intermediate state. In this intermediate state, what you have, this bond is forming, this bond is breaking. OH bond will be formed and CCl bond will break when the reaction will take place. So this is an intermediate. In this, you can see carbon is having 5 atoms, 5 species.
Yes, sir.
Which is a very unstable situation. Unstable. This is called a transition state. Transition state, which exists only for a short period of time, cannot be isolated.
Hmm.
Cannot be isolated. So, what is the result? This is unstable form. Carbon can have maximum valency 4. Here, there are 5.
Yes, sir.
Immediately, it will get relieved and remove the Cl minus and form the product. This is an example of SN2 reaction. This is a, you can see what type of alkyl halide is this, CH3Cl. There is no carbon, so this is actually 0 degree. If I have CH3CH2Cl, this is this carbon has 1 carbon, this is 1 degree, 1 degree. If carbon has 2 carbons, 2 degree. If carbon has 3 carbons, 3 degree. That you already know. Okay?
Hmm.
So here the no problem was there for the incoming nucleophile. And in such cases, as you can see here, nucleophile attacks the leaving group. This is the leaving group. This is plus, this is minus, it leaves.
Hmm.
And this is my product. This is my product. Okay?
Yes, sir.
Well, can be OH minus, CN minus, you have seen OR minus, all these groups. And in such reactions, the rate in chemical kinetics you have studied is equal to rate constant, and it depends on the concentration of the nucleophile, and also the rate depends on this R alkyl halide. It also depends on this here CH3Cl. Okay? So what is the order 1 and 1? 1 plus 1 means 2. Therefore, this is called bimolecular nucleophilic substitution reaction. That is why we have said SN2. Okay? 2
Yes,
means
sir.
you can see there are 2 molecules, nucleophile as well as CH3s, which are involved in the rate determining step. Therefore, the rate is given by 1 plus 1, 2 order, which we say bimolecular. Now the question is the order of reactivity. Supposing here that hydrogen atoms are very small. What will happen if I put very bulky groups here? If I attach, this is the leaving group. If I put very, very big groups here, A,
Yes, sir.
B, C, if these groups are fatty groups, very big group, what will happen? Then it will be very difficult for the nucleophile to attack this carbon.
Yes, sir.
And then this mechanism will be hindered. This is called steric requirement. So sterically hindrance will be there. Because if I put CH3, 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 then they are big groups. What will happen? The SN2 mechanism will be slowed down to a very big extent, because it will be very difficult for the nucleophile to attack this carbon. And therefore, we can say that for SN2, the order of reactivity is as we have shown here. This is 0 degree carbon, 1 degree,
Mm.
2 degree, and 3 degree. This is the order of the reactivity.
Yes, sir.
Order of the reactivity. So their question is coming on this. That's why we have to be sure. This is the order of the reactivity. Reactivity order is very important for SN2. In fact, the tertiary will not undergo SN2 reaction because of the presence of CH3 groups are very big. Hydrogen was very small. So you can see this is how the SN2 mechanism proceeds. Any doubt?
No, sir.
Okay, good. You have noted down. We are going further.
Yes, sir.
Now we are saying, if I see the stereochemistry, what is stereochemistry? We are going to talk of this in another topic, stereochemistry of the nucleophilic substitution reactions. This is a very important point. This question has been asked in the papers. Last year also there was a question on stereochemical aspects, which we will be discussing optical activity and chiral and achiral carbon, everything. In SN2 mechanism, nucleophile is attacking from the backside. If this carbon, I'm saying, this is a leaving group, it could be FBr. If this is attached to different groups here, all the 4 groups are different. If this carbon is chiral, we will tell you what is chiral. Then what will happen? There is, you can see that nucleophile is coming from the backside and leaving group is leaving from this side. You can see there is an inversion of configuration. We will explain more about this in the stereochemistry of this. Inversion of configuration takes place in SN2 mechanism. In which one? SN2. These are the points to be noted. They will become questions in the paper. Now the question is, what type of solvent we are using? Because in this, the reactivity, there is, you can see that in this 5 intermediate, which no ions are being found here, no ions are being produced here. So we can say that polar aprotic solvent, because there is no hydrogen bond or anything like that, which is formation. So polar aprotic solvent can be used to enhance reactivity of the nucleophile and help promote SN2 reaction. And the leaving group also is important. If the leaving, which group is leaving, and we will see nucleophile is attacking, the leaving group leaves. And we have seen the order of reactivity: 1 degree, more than 2 degree, more than 3 degree. And if I see the order of the leaving group, you will find I minus is better leaving group than Br minus, then Cl, then F minus. This is the best leaving group.
Yes, sir.
Because you can see this has a larger size, and therefore the negative charge is spread over a larger surface area, larger part of the molecule. This is more stable as compared to this. This is more stable than this. Therefore, this will leave better. So this is the order of the leaving groups. Here now we are coming to the second mechanism, which is SN1. As I said, if I attach very, very bulky groups, for example, if I have this compound CH3 CBr and I put aqueous sodium hydroxide, what will happen? Now in this, what is the story? But how it looks like? This is my Br.
Yes, sir.
And if you are putting, this is your CH3. This is what you are having. You can say dash to CH3, and you have then CH3 group. Now these are very big groups. Very big groups. You can see one CH3. How it looks like? CH3 is this group.
Yes, sir.
There are 3, And can the OH minus come from this side? Now,
No, sir.
sterically, not possible. There is a lot of steric inhibition. What do we call it? Steric inhibition. Very much crowded, huge crowd is there. So how it will come? No. Then what has to be done? Only one possibility, if this leaving group leaves before the reaction takes place. I'm saying the leaving group leaves before the reaction takes place. Before the OH attacks carbon, this leaves.
Yes, sir.
Why will it leave? That conditions have to be created in the reaction so that it leaves. If it is a good leaving group, it goes by itself. When it goes by itself, what happens? Then if supposing this is the tertiary alkyl, this is a 3 degree, this is a 3 degree. 3 degree alkyl halide, tertiary. What happens? It will proceed in two steps. In the first step, the leaving group leaves. And you get the formation of a carbocation. What is this?
Yes, sir.
Carrying a positive charge. Carbocation. The carbocation is sp2 hybridized. This is sp3 hybridized. You know, carbocation is a planar, as you can see the structure of this. Okay? This is a slow step. This is the rate determining step here. This is the rate determining step here. Step 1. After this carbocation is formed, now the nucleophile can come and attack. It doesn't matter. You can take a strong nucleophile or a weak nucleophile. All can attack this because this carbon has positive charge. And this is planar. They can come from the top. They can come from the back, bottom also. So what will happen? 50% can come from the top, 50% from the back, lower side. Because this is a planar molecule, so there is going to be attack of the nucleophile from the top and the bottom. So what you will get, that reaction will take place. The second step is very fast, which is the nucleophilic attack on the carbocation. This is step 2. So in this case, the rate will be determined by only the alkyl halide, because nucleophile attack will be very fast after the group has left, and doesn't matter whether it is a strong or a weak nucleophile. Therefore, this reaction is following first order. Okay? And it only depends. Rate depends on the concentration of the alkyl halide. What you are saying? The rate is here proportional to what is this? CH3 3 times CBr. That's all. It doesn't depend on the nucleophile. So what will be the order here? Only one. So this is called SN1 or substitution unimolecular. Okay? Any problem here?
No, sir.
Okay. Further, what happens now? देखो कि in SN1 mechanism, carbocation is formed. What is formed? Carbocation. So those reactions in which stable carbocation can be formed, they will proceed through which mechanism? SN1. And we already told you when we discussed the stability of the carbocations. When I discussed the stability of the carbocations, you know what we said. 3 degree carbocation is more stable than 2 degree, more stable than 1 degree, more stable than 0 degree. You know that? You know the reason also?
Yes, sir.
What reason was given? Hyperconjugation?
Yes, sir.
Hyperconjugation. So this carbocation stability is this. And there are certain other carbocations also which are stabilized by resonance. There are certain carbocations which are resonance stabilized. Can you give me an example of resonance stabilized? Resonance stabilized carbocation. Can you give me example of resonance stabilized carbocation? We have listed here. What is this? What is the name of this? What is the name of this, students? What is the name of this carbocation?
Yes, sir. Benzene.
This is not benzene.
Okay, so you're writing more. Okay.
What do you call this?
Sir.
If I put CH2Cl, what is the name of that compound? This is our benzyl carbocation.
2 minutes, sir. Sir, this is benzyl chloride.
This is benzyl carbocation.
Yes, sir.
This is a stable carbocation because of resonance. What happens? This pi bond can shift, and you have how many resonance structures I can draw. Here I have shown the resonance structures of benzyl carbocations. What is happening? You can see this pi bond is shifting, and then it becomes positive. Then this shifts. So how many structures I could draw here? For this, you can see carbocation. I have drawn these structures of the carbocation. We have shown here 4 structures of the resonance stabilized. Benzyl carbocation is quite stable. The stability may be equal to the 3-degree carbocation. 3-degree carbocation. Because 3-degree carbocations are also stable. So in reactions where such a carbocation can be formed, the reaction will prefer to go by SN1 mechanism. Similarly, one more I told you, allyl. What is allyl? If I have a double bond, if I have a carbon, what is this known as? What is this? Double bond, single bond. This is called allyl carbocation. Here what happens? This pi bond can shift due to resonance. What happens? This is stabilized. It has 2 structures. So few carbocations are stable, which are important. For example, benzyl, allyl, they will follow. If such are formed, then they will prefer SN1 over SN2 because there are only 2 mechanisms. One is SN2, other is SN1. When less hindered carbon is there, naturally SN2, and if you have more hindered carbon and stable carbocation is formed, naturally the preference is SN1.
Yes, sir.
So in a competition of SN1, SN2, we know here we have shown the order of SN1. Because this is the least. This is primary, this is secondary, this is a tertiary. Tertiary is also allyl equal to allylic halide. And this is the tertiary, this is the tertiary, this is the secondary. This is 0 degree, 1 degree, 2 degree. This is my 3 degree carbon. What is this compound? Tertiary alkyl halide. You can see bond line representation. And benzyl, this is what benzyl. They are quite almost same. They are also stable carbocations.
Yes, sir.
So we can say that the order of reactivity will be then. Order of reactivity will be then what? The order of reactivity will be what? For SN1, 3 degree, greater than 2 degree, greater than 1 degree. This is the order of reactivity.
Yes, sir.
And the best leaving group, again we have shown Ri faster than RBr, RCl, RM, because the size of I minus is larger. Okay?
Yes, sir.
Best leaving group is I1, I minus. This is the best leaving group, as we have shown. Because the size, you can see the larger in size, smaller, smaller. The larger in size, the negative charge, it will be a better leaving group. So here we have shown you that the order of SN2 is tertiary less than secondary, less than primary, and 0. And for SN1, the order is tertiary more than secondary, secondary more than primary, primary more than 0. Okay. You have noted down this?
Yes, sir.
Okay.
I think so. 2 minutes.
You can note down important point. The one question is coming in the paper on this mechanism. One question is always there on mechanism of the nucleophilic substitution.
Done, sir.
Okay. Here you see we have shown if you are given these two, if I react with NaOH and NaOH, which will react faster? Dekho, here this is a much better leaving group, NH3 ammonia. Here the leaving group is Br minus. So this will be very fast. This is faster and this is slower because the leaving group is ammonia. It's a big group.
Yes, sir.
A much better leaving group than Br minus. What is this? This is a leaving group here. NH3 plus. It will take the electron, go, and here Br will leave. And this will form Br minus. This is a better leaving group. This is faster. And sometimes the solvent effects are important. You know, solvent, because carbocation is a ion, positive ion.
Yes, sir.
If it is solvated highly, then it will become more stable.
Yes, sir.
Solvating power. So you can see if I react this compound with Cn minus. What is this compound? You are having, this is CH2, CH2Br. This is a compound. And what we are doing here, the important of polarity and solvating power. If you are removing this group, what is happening? You can see if you are using Cn minus, then where the relative rate is higher. This is much higher than this. If I use water as a solvent.
Yes, sir.
And if I use CH3OH, then the rate drops. Water is having high polarity and high solvating power. Water is having high. Actually, this some mistake is there. I think it should be, this compound should be this one. Because SN1 means that benzylic should be formed. I am replacing this with the Cn minus.
Sir.
Because this is my benzylic carbon cation that will follow SN1 reaction. Which one? Benzylic carbocation. This is not benzylic. This is not benzylic. So I will remove this one. CH2Br. I am saying the compound will be CH2Cl. CH2Cl. Okay. So this is the compound which we are forming.
Yes, sir.
What we are forming? CH2Cn. And the carbocation which you are talking is which one? CH2 plus. This is a benzyl carbocation. It is resonance stabilized. So this is very good for SN1 condition. Benzyl carbocation. And this will be solvated more by water. Water is has high polarity and solvating power. High polarity and solvating power.
Yes, sir.
As compared to CH3OH, alcohol. Therefore, the rate is 1,50,000 more times than this. See how much rate difference is there. And effect of nucleophile, for SN1 reaction, I told you, nucleophile does not affect the reaction.
Yes, sir.
It does not depend on the nucleophile. Weak or strong makes no difference. Nucleophile does not affect. Why?
ठीक है sir.
Because the leaving group has already left. Carbocation is there. You can have weak nucleophile or strong. Both will attack at the same rate. The reaction is very fast, so no problem. Okay, this is clear.
Yes, sir.
Okay. Now the questions have come before us. Questions are very important. That every time there is a question, students, questions are coming answered by us. In the exam, what you get only questions.
Yes, sir.
First question: in the following pair of halogens which undergo SN2 faster, you are given these two compounds. Which is faster, this one or this one? You will get only 1 minute for answering any question.
Okay, sir.
SN2 he is asking. Which is faster in SN2? This compound. This compound. SN2 which will be faster? This one or this one?
This one, sir. This one.
Which one?
Left or the left?
This one. Why?
Yes, sir. Yes, sir.
Why?
No, sir, I meant the right one, right one.
Right one will be faster. Why? In SN2, what is the order? 1 degree more than 2 degree, more than
3 degree, yes, sir.
What is this carbon? This is
1 degree, sir.
Carbon here. How much?
Okay, sir. 2 degree, 2 degree, this is 2 degree.
Where is 2 degree? This carbon is attached to only one carbon. Where is 2 degree?
Yes, sir. One is Cl.
What is about this?
I'm confused. So this is also one.
Where is one? There are 2 carbons here.
I'm getting confused. Making mistake. Yes, sir. Sorry.
This carbon attached to 2. This is 2 degree. Therefore, this will be faster than this. You have to give reason. You have to give reason. 1 degree. This is 1 degree carbon. This Cl is attached to this carbon. This is attached to only one carbon. 1 degree. This carbon is attached to Cl and how many? 2 carbons.
Yes, sir.
That's the bond line representations. Because what is you have? CH2, 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 CH2. See, this is a compound.
Yes, sir.
CH2, CH2, CH2. So this is faster. In these two, which is faster? This one or this one? Which is faster?
Sir, out of these two, 1, 2, 3. Sir, right is faster. Right is faster. Right one.
This one?
No, sir. So out of these, yes, sir. This one.
This one?
No, sir. I with I.
You have to give reason why. This is faster than this. What is the reason?
Sir, the reason is because
I minus is better leaving group.
So 2 minutes. Sir, answer wait 2 minutes. Answer wait 2 minutes. 2 minutes.
Which is better leaving group? Because they are same. This R is same. R is same. Only Cl.
2 minutes, sir. I'll give the reaction. 2 minutes, sir.
I is a better leaving group than Cl. So this will be faster.
Yes, sir. I because I is less stable than CCl.
So this is a better leaving group. Answer is I minus is better leaving group. But that's
yes, sir.
all
Yes, sir.
yes, sir.
Yes, sir.
And you have to show it. Predict the
No, sir.
reactivity of the following compound in SN1 and SN2 reaction. Now here is another question.
Yes, sir. Yes, sir.
He says there are 4 isomeric bromobutanes, and we have to arrange them in increasing order of SN1 and SN2, both. So when such questions are given, sometimes the question is given on isomers. This question also involves this question 1. This question also involves isomers. First, we have to draw the isomers of bromobutane. What is the compound? Bromobutane.
Bromobutane.
How many isomers will be there? First, we have to check it. First, we have to draw the isomers of bromobutane. Then we will see SN1 or SN2. I will give you 1 minute. Okay. Can you draw the isomers of bromobutane? Isomers are very favorite question in the papers, in the exam, I am telling you.
Yeah, I'm drawing for 2 minutes.
You try this, then we will give answer to this.
Yes, sir. The isomers of bromobutane. Yes, sir. Sir, one is one is 1 bromobutane. Second is 2 bromobutane with the Br on the second CH. So third is 2 bromo 2 methyl propane.
1, 2, 3.
Yes, sir.
Then I can put supposing these are the isomers. Now you have to say first, let us see the SN2 order. First, you write the SN2 order. You have 1 minute.
Yes, sir. Sir, what?
SN2
okay,
order.
Yes, sir. Writing. SN2. Yeah, I'm done, sir.
What is the answer? What is this carbon?
Sir,
1 degree?
Sir, yes, sir. First will be C6H5CH2Br.
This is 1 degree carbon. This is
yes, sir.
2 degree carbon.
C6H5CH2Br.
What is this? This is also 1 degree carbon.
Yes, sir.
1 degree.
Second will be C6H5CH3H3Br.
That means if I name this as 1, I'm changing the color because there is some problem. If I say this is my number 1, if I say this is my number, I'm this 2, this I'm putting 3, this I'm putting 4. Okay?
Yes, sir.
SN2 means 1 degree, which is 1 degree. Which is 1 degree. Which is 1 degree. This one.
Yes,
so,
sir.
Number 1 is the fastest in SN2.
Yes, sir.
After this is also 1 degree. This is also 1 degree, as you can see. But some sterically hindered here, but not at this carbon. So after this will be number 2.
Yes,
and
sir.
3 is 2 degree. You can see 2 groups, bulky groups on 2 sides. After that is 3. And this is the most hindered.
Yes,
3
sir.
degree, 3 degree. So the order is this one. The decreasing reactivity of SN2 is this one. Any doubt?
No, sir.
And SN1, the order will be reversed. What will be that? For SN1, 1 less than 2 less than 3 less than 4. ठीक है?
Hmm.
So this is how
Yes, sir.
questions will be answered in the paper. I am telling you, one question is coming.
Hmm.
One question is coming.
Okay, sir.
And one more question is there, which is more difficult, but some part of this can come in the paper. This is number 2. This question. You have 1 minute to. First, you have to draw the structures of these, and then only I can give the answer.
Okay, sir.
This is the second first part. Let me rub this.
Done, sir.
Okay. This is an important question for the paper, I am telling you.
Hmm.
One question like this is coming in the paper. Every year. SN2, SN1. Order of reactivity, very important question. Okay.
Yes, sir.
First, we should be able to draw them.
Hmm.
Therefore, first compound is C6H5 CH2Br.
Yes, sir.
This is my first compound. Second is C6H5 CH6H5. ठीक है?
Yes, sir.
C6H5 and Br. ठीक है?
Yes, sir.
Third compound is C6H5 CHCH3 and Br. ठीक है?
Yes, sir.
I'm giving, this is my number 1 compound, this is my number 2 compound, this is my number 3 compound, and the last one is C6H5 C6H5 CH3 and B. ठीक है?
Yes, sir.
First I go for SN2.
Tell
me SN2, which carbon? This carbon is 1 degree.
Yes, sir.
This carbon, there are 2 carbons, 2 degree. This carbon is also 2 degree. This carbon is a 3 degree. And also these are big groups. Size is increasing.
Yes, sir.
So which is the fastest? SN2. Which is the fastest out of these? Which has the highest rate? Order of reactivity? You have to.
I'm telling, sir.
Huh?
Yes, sir.
Which one? For SN2, what
Sir,
is
the
order?
highest? Yes, sir. The highest is in C6H5. C6H5.
Give me the number. Number I have given.
H2Br.
Are number? Give me the number.
Achha, number, sir.
Number 1.
Number, sir. First is the fastest.
After this, which is coming the second?
This is CH3. Sir, third.
Third.
Yes,
because
sir.
CH3 is smaller than C6.
Yes, sir. Yes, sir.
After that?
Sir, then after that, second is the third fastest, and fourth is the last.
SN2. Then what will be SN1 order? SN1 order will be 1 will be less than 3, will be less than 2, will be less than 4. ठीक है?
Yes, sir.
This is the order of SN1. Or you say 4 is more than 2. 2 is more than 3, 3 is more than 1. This is the order.
Uh,
Decreasing, increasing. Depends on
Hmm.
what type of question is given.
yes, sir.
Any doubt? This is an important question I'm telling you. If you have doubt, you can ask me.
ठीक है, sir. No doubt, sir.
This ends our mechanism and important questions of nucleophilic substitution. But one or two more questions because there is another chapter coming, stereochemical aspects of nucleophilic substitution reaction.
ठीक है, sir.
That is a complete topic which we want to discuss in that. For example, what was given in the questions. Here is a question. Which alkyl halide from the following pair would you expect to react more rapidly by SN2 mechanism? Question. You are given these two compounds. Which will be more faster, this one or this one? SN2. For SN2, he is saying you have this compound and this compound.
Yes, sir.
Which is going to be faster, this or this?
One, sir.
One?
This, sir. This. One.
Why?
This.
This is faster than this. Reason.
Again, sir. Let's.
Reason has to be given in exam.
Okay, sir.
What is the reason?
Less stable, sir.
Huh?
Less stable, sir.
What do you mean by less stable? That is not the answer. What reactivity order I have told you for SN2? What is the order of reactivity of SN2? You have noted down. What order you have noted down? For SN2, what is the order of reactivity? You have noted down.
Sir. Yes, sir. I have noted down, sir.
Huh? You
yes,
have
sir. The
notes?
order of reactivity of SN2. Yes, sir. Seriously, wait a minute. Sir, methyl. Sir, 1 degree, then 2 degrees, then
and
3
then
degree.
you answer according to that. 1 degree is more than 2 degrees, more than 3 degrees.
Then
what is this carbon? Which is 1 degree or 2 degree?
1 degree, 1 degree, 1 degree.
And you have to write in the answer. What is this carbon?
2 degree.
2 degree. Then what is the answer you are giving? We have shown you everything. Order of reaction.
Yes.
This is faster than this because this carbon is 1 degree, this carbon is
1 degree.
And what is the story here? Second question.
Here, sir, one is smaller because one is 2 degrees and C is 3 degrees into.
So which will be faster?
1, sir.
Okay.
Yes, sir.
What about this?
Sir, they'll be same. Sir, both are 3 degrees.
What are both?
3 degrees.
Where they are 3 degrees?
No, okay, fine. In one is 1 degree and in two, 1 degree both.
Both,
Sir,
1
both
degree.
are 1 degree.
But where is
1 degree,
steric
1 degree.
crowding more? This is 1 degree. This is also
this is also 1 degree.
But crowding is more where?
Okay.
This or here?
Yes, sir.
Huh?
Yes, sir.
Which is faster than? Here the CH3 group is nearer to this. Here the CH3 group is away from this. So where the crowding will be more? In this case, because this CH3 is coming closer to this. This CH3 is far away from this.
Yes, sir.
So what will happen? This will be faster than this.
Okay, sir.
Now question 10.8. In the following pair of halogen compound, which compound undergo faster SN1 reaction? Now he is comparing the rates of SN1. Very important. One question is coming in the paper. I am telling you. Which will be faster in SN1? This one or this one?
Telling, sir. Sir, fastest will be 1.
Why? Give me the reason also.
Sir, because 3 degrees.
3 degrees. This is the carbon.
Yes, 3 degrees, sir.
This 1, 2, 3 carbon. This is 3 degrees.
Yes, 3 degrees, sir.
So what is the order of reactivity of SN1? 3 degree more than
2 degree to 1 degree.
This is, you have to remember, know this now. That is the question.
Yes,
questions are coming on this basis. So this will be faster than this. Is it 2 degree? What about these two? Which is faster?
Again, sir, First one, because it's 2 degrees.
This carbon, this is 2
2
degrees.
degrees, sir.
What
Yes,
is
sir.
this?
And this is 1 degree.
Carbon,
1
carbon,
degree. 1 degree.
1 degree. This is
Yes, sir.
all right. These are some of the questions which have been asked in the exam. So, I mean, when we do it, whenever we study something, we should be able to solve questions in the exam. Whatever lecture I give, there are a lot of questions. Always I'm telling you for the examination. Every lecture. When you get a video recording, you listen to it before paper, you will get almost all the questions in the exam.
Yes,
so
sir.
whatever I teach, I give question, answer to all the students. I'm telling you. So you be careful. Unless you will pay attention, you will be the loser. You pay attention, you make notes, you can listen to the video later on, and you will get a lot of question answers which have been asked in the exams. Previous board papers also. And
yes, sir.
A lot of questions are coming and repeated. So important questions are asked in the paper. You know about that.
Yes, sir.
Why do we do sample papers? Because they are going to be there. So that is why I say you solve the question. Let us see what is your difficulty. If you have any problem, any difficulty, you can ask me, no problem. This is not your final paper here. Here we are trying to understand and learn the chemistry. We are not cramming the things. If you cram, you will not do anything in paper. We have to learn the things which are required. That is my job only. So you can ask me any question, no problem. Okay, then good night. We will meet you in the next class. You made a good attempt. And I want that you should use your mind and start thinking. And be serious about your work. The time is less. Your exams will proceed very fast. And students who are not completing their course, they will be in trouble. Because they will be nervous. And they say, oh, we don't know anything because schools were not working. No issue. Exam means exam. And you know they have to be there. Can there be no exam? Is it possible? The answer is no. So you prepare yourself. And if you have any question, you can ask me. Okay?
Oh, of course, sir. Yes, sir.
Okay, then good night. We'll see you.
Okay, bye, sir.
Try to finish your course as fast as possible. Okay, bye.
Of course, sir. Yes, sir.
Okay.
Bye, sir.
Bye. Good night.
Good night.